Hi everyone, my name is Anissa Nur Nabila and I'm an undergraduate informatics student from University of Brawijaya.
My name is Dimas Anandar Ditya. I'm from University of Indonesia, majoring in materials engineering, and I'm a fresh graduate now. And we are from Team 18 called MIB.
And this is our presentation for UNICC Global Hackathon for the challenge to refugees crisis. The purpose of this challenge is to develop a model to forecast different stock figures of forcibly displaced persons by country or of origin 5 years from now.
And in order to solve this problem, we used the 5 sources of primary data and the 2 additional data. And for the main data, we got from the UNICC committee, and for the additional also we got from the UNICC committee. And in order to the fastness of the data in limited time, we'll focus solely on the main data set in order to get the straightforward solution. So we set the forcibly displaced CSV as our primary main data, and the rest of the main data, we set it as the secondary main data. So for the beginning of our exploration and our understanding of the data, we do some line plot for the target variables, which is REF, IDP, and ASY. So according to the plot that we already conduct, the trend for the target variables is intended to be the increase in each year. And with the highest value in the IDP target values, with approximately about 42 millions of people. And after that, we also explored some of the origin countries and the top 10 asylum countries. And for the origin countries, we define it as the unknown countries and known countries. And for the unknown countries, it's about 3.21%. And for the red figure, it visualized the top 10 asylum countries, which USA is the most favorable countries for the refugees, and followed by Canada, and the rest until the 10th position. In order to explore the data more deeper, we conduct some geospatial data visualization. As the left figure, it indicates that the crisis indicators locations, which means that these plots help us to understand the countries of origin of migratory flows. Meanwhile, on the right screen, this plot is used to understand the countries, risky until dangerous events, which affecting the migratory and the countries.
And for the approaches, analysis of the migratory flows when both the country of origin and the country of destination are known. In this case, we have relevant information about the fatalities, geographic characteristics, and bilateral distance. And the second one is analysis of the migratory flows when either the country of origin or the country of destination is unknown. In this case, the available information is limited and the prediction is based only in the data obtained from the previous years. For building our model, the first thing we do is merging the important columns into forcibly displaced data. We make a new dataset by choosing the most important columns on the secondary main dataset, hypothetically, and then join into forcibly displaced. The new dataset is used for modeling the two defined approaches. But the several columns are detected to have a missing values. Therefore, it needs to be handled in order to avoid the improper feature of model building.
Okay, so before we move to the modeling section, we plot some correlation metrics for the target variables, which indicates that the target variables least correlate with the other columns. And for the next, after we do some visualization on correlation metrics, we do some data preprocessing and some bit zero engineering, which is consists of cleaning, imputation, encoding, and the scaling. And after that, we use the simple linear regression as our predictive model, and we use the evaluation score of R² as our evaluation score. And next, for the modeling 2, it is in order to dealing with the unknown refugees. So the number of refugees that come from an unknown country cannot be ignored. So if we know the destination country, the best approach is to use the linear regression model. So based on the left figure, on the y-axis, the number of refugees displaced abroad that obtain refugee status is shown. And the linear regression line is tend to be steep down rather than increasing. And after that, For the model 2, we use the time series analysis in order to forecast the 5-year ahead. And for the ARMA, is for the RFE target variables, and for the ARIMA is for the ASY and the other target variables. So for the ARMA 1.0, since the values of our model interpret 0 on predicting the number of REF for 2020 until 2025, it means that there will be no significant increase for 5 years ahead. Meanwhile, on the ARIMA models, since the values of the model is interpreted by 1, and the further prediction for 5 years ahead is stagnant, it means that for 5 years ahead, the values will be updated from the last year values.
And due to our bad results on performing model 1, which is like linear regression, we believe that our model is still not well refined because of several aspects. Maybe because of we chosen the wrong variables. But however, using ARIMA creates a better representative results using raw UNICC Hackathon dataset. And as a conclusion, when we don't know the country of origin of the refugees, our prediction can only be based on the values of the previous years. Therefore, the best approach would be to use forecasting models. However, when the data is limited, we can use naive models that use the value of the last year as a prediction. And that's all from us. Thank you so much.